Well, we're on to another unit and a new idea. So the I can statement for section 4.1 is I can find unit rates, right? The word unit right there, and identify proportional relationships. So we're going to write the word proportional relationships. So in the warm-up question, and a lot of the stuff that we talk about today is going to be a little bit of review. I'm hoping this rings a bell for some stuff that you've covered before in maybe 7th grade or something. So the warm-up first question is, what is a ratio? A ratio is a comparison of two numbers. It's a comparison of two numbers. A lot of times we'll write things like this. We'll do 3 and then colon 4, or we'll write it with the word 2, or a lot of times we'll write it this way. We'll write it as a fraction, and this is probably the most typical way we'll do this because it kind of lends itself to working in math. So I'm going to put a dotted circle around that. Next one, again, review. Graph the point -2, 4. So we've got the xy plane here. Remember, the x is always first and the y is always second. This means we're going to either go left or right. Let me write left or right. And this is going to be up or down. And that's from the origin, and the origin is right here. So remember, the x-axis is right here, the y-axis is right here. So we're going to go to -2 on the x-axis, so that means we're going to go back 2 units. And then the y-coordinate is +4, so that means we're going to go back 2 units and up 4. So 1, 2, 3, 4. So we're going to end up right there. Okay, that's the point that we're interested in on part B. And then it says, what are the coordinates of point P? So point P is right here. Now notice from the origin we have to go over 1, 2, 3, 3 units to the right. Okay, so the x coordinate is 3, so I'm going to put a 3 right there. We always do the x coordinate, the horizontal coordinate first. And then the y coordinate would be up 1, 2, and that's in the positive direction, so we're going to put 3, 2. So I'm just going to write 3, 2 right here. So we've got the answer. And good with the warm-up there. Now let's talk about unit rates and proportional relationships. So a rate is a ratio. Okay, so a plain old rate is a ratio, and what it's used is it's used to compare two different types of quantities or measurements. Now some people think there's a huge difference between a rate and a ratio. I happen to think that it's just a matter of the words that we use, but some people make a big deal of that, so keep that in mind. So let me give you some examples of some common rates. Some common rates would be things like this: miles per hour, that would be a very common rate that we talk about. Dollars per hour or per minute or something like that, or cost per item, or anything where we're comparing one type of quantity with a different type of quantity. Notice this is money and this is a unit of time right here, and this is a measure of distance and this is a unit of time. So when we're comparing those different quantities, then we'd be talking about a rate. So I'm going to give you an example, and on this one I'd like you to write a rate for each one, but do not reduce this, and I'm going to show you why we're not going to reduce it in just a second. And just a reminder, labels are really important when we're talking about rates because we are comparing two different things. We want to keep track of what we put on the bottom and what we put on the top. So Nick traveled 150 miles in 2 hours. So that means the rate would be 150 miles, and we're going to abbreviate that with MI, and 2 hours is going to be on the bottom. So we're comparing 150 miles to 2 hours, so there's our rate. Again, we're not going to reduce that. Jordan traveled 210 miles in 3 hours. So 210, we're going to put the miles on the top, and then we're going to put 3 hours on the bottom. Okay? So the problem with writing rates like this up above is it makes it really difficult to compare. A normal question here would be, well, who was going faster? Was Nick going faster or was Jordan going faster? Nick didn't go as far, but he didn't travel for as long. He only traveled for 2 hours. Jordan went further. She went 210 miles, but she did that in 3 hours. So it makes it kind of difficult to compare. Now, that brings up what we call a unit rate. So a unit rate tells us how many units of the top quantity corresponds to exactly 1 unit in the bottom quantity. So the thing that makes these difficult to compare up here in the first example is this is compared to 2 hours, a distance compared to 2 hours, and this is a distance compared to 3 hours. So most of the time we almost automatically change rates like these into a unit rate. So let's take these and make them into a unit rate. And we do that by making sure that the denominator is a 1. So let's go ahead and divide the bottom by 2 and the top by 2. Or what we actually do here is we just take 150 divided by 2. So that would be 75 on the top, 75 miles on the top, and 1 hour on the bottom. So this would be 75 miles per hour. If we take the 210 and divide it by 3, we end up with 70 on the top, and we end up with 1 hour on the bottom. So there's our unit rate. Now you'll notice that because they're both compared to 1 hour, that makes it very easy to tell who was going faster. In this particular situation, Nick was going faster. So let's take a look at another example. We're going to write the unit rate for each situation. It does say unit rate here, so we want to make sure that the denominator ends up a 1. And we're also going to label here, because again, that's really important for keeping straight which is which. So on this one, Kay did 128 sit-ups in 4 minutes. So we're going to do 128, and I'm just going to abbreviate with SU, in 4 minutes, MIN. And then Berkeley did 112 sit-ups in 3.5 minutes. So 112 SU, we'll abbreviate there, same abbreviation, in 3.5 minutes. Now again, it's hard to tell who was doing more sit-ups per minute. So that's what we're going to do here. We're going to change this into a unit rate. So I'm going to grab the calculator. I'm going to take the 128. And if you can take a guess at what this is in your head before you type it into the calculator, that would be awesome. So we're basically going to reduce this. We end up with 32. So 32 sit-ups per minute. And I can just write minute right there. If I wanted to write the 1, I could. Kind of reminds me that I've got a unit rate right here. And let's do the other one. So this is going to be 112 divided by 3.5. So 112 divided by 3.5 is going to give us 32, in this particular case, 32 sit-ups per minute. Okay, this one I'm going to write the 1 on over here on Berkeley's unit rate. I'm not going to write the 1 just to show that we can do it both ways. So Cade did 32 sit-ups per minute and Berkeley did 32 sit-ups per minute. She did do less because she took less time to do it, but they were doing them at the same rate, so they were going just as fast as each other. And again, it's much easier to compare this if we have this written as a unit rate. So situations where the unit rates are always the same, so we're going to underline the word always, they are called proportional relationship. Proportional relationship. So if the unit rate is always the same, that's called a proportional relationship. Now if the unit rates are not always the same, then we call it a non-proportional relationship. So those unit rates really allow us to tell the difference between a proportional relationship and what we call a non-proportional relationship. So let's take a look at example 3 at the bottom of this page right here. We're going to be doing several calculations. We're going to start off with just these first 4 situations right here, and this is for a purchase. It's for a purchase of a certain number of pounds of candy, and then the price that we paid for that candy is right here. We're going to show a little bit of work, and then we're going to write down the unit rate with a label. And your assignment is very similar to this. There's some problems just like this. Now, by convention, we normally put the second measurement on the top. When it's written in a table like this, we normally put the second one on the top. And definitely when we're dealing with money, we normally put whatever the money unit is on the top. So here's how we're going to go through and do this. 4 pounds of candy costs $13.08. So we're going to do 13.08. We're going to divide that by 4. We're going to keep in mind that this was dollars and this was pounds. So this is $13.08 for 4 pounds of candy. Now we're going to grab the calculator and we're going to do the work for that. So we're going to do 13.08 and we're going to divide that by 4 and we end up with 327. So here's what this means. This means $3.27 per. Now remember, what we basically did is we divided the top by 4 and we also divide the bottom by 4. That's why we want this to turn out to be that's how we're going to get this to turn out to be a 1. So this would be 1 pound on the bottom. Okay, so $3.27 on the top, 1 pound on the bottom. Make that look a little bit better. Slide that over. Remember, LB is the abbreviation for pound. Sounds weird, but that's what it is. So here's the unit rate with the label. So I'm going to shorten this work in just a minute, but I've showed everything here. So we're going to write this down. We're going to write down $3.27 per pound. And you'll notice that I didn't write a 1 there. That is an L. Because if we don't write anything on the denominator, it's assumed to be a 1. So this is $3.27 per pound. If we wanted to, we could write it like this, $3.27 per pound. That would be totally okay. Either way is fine. I kind of like the fraction because this is a math class and we tend to deal more with fractions than we do with things written in words. So let's continue with this one right here. And to make this a little bit easier, I'm going to go through and I'm going to write down each one of these ratios or each one of these rates in its unreduced form. So I'm going to write 1635 divided by 5. I'm going to write 3597 divided by 11, and I'm going to write 4251 divided by 13, and we're going to grab the calculator and we're going to type each one of those in. So we've got 1635, we're going to divide by 5, and we get 327. Next one is 35.97. We're going to divide by 11. Make sure we hit the divide there. Divide by 11. And we get 327. So all of the answers so far are 327. Let me do the last one. Let's see how this works out. 4251 divided by 13. And they all work out to be 327. Okay, so there's the work. And if you wanted to, you can just come over here and you can write down 327 per pound. 327 per pound. And 327 per pound. Okay, so we've shown the work right there. We'll just assume if we didn't, show any more work by hand or something like that. You don't have to write this down every single time, but you do have to write this. This stuff is definitely required. Shows that you're setting up the rate the right way. Now, we've come over here and we've written down the unit rate for each one of these. So what this means is every single time we buy a pound of candy, it costs us $3.27. It doesn't matter whether we're buying 13 pounds or 10 pounds or 3 pounds or 5 pounds or whatever it is. We're going to pay $3.27 per pound. So the next question is this proportional, yes or no? Well, the unit rate is always the same, so that's going to be a yes. And we're going to say that. We're going to say the reason we know it is, we're going to say unit rate is always the same. Unit rate is always the same. If the unit rate is always the same, it's proportional. If it's not always the same, then it's not proportional. We say it's non-proportional. So we're going to add another purchase. What if we added a purchase of 15 pounds that costs us $48.75? So let's show the work. $48.75. Again, the money usually goes on the top. The second quantity goes on the top. The first quantity in a table usually goes on the bottom. So we're going to divide that by 15. So let's see what happens here. 48.75, and we're going to divide that by 15. So we end up with $3.25. So this would be $3.25 per pound. So there's our answer right there. Now, if we added that purchase, would it still be proportional? And the answer to that is no, and we would just say not the same unit rate. Now, this does happen quite often. Maybe at this particular merchant, once we get over 15 pounds, once we're buying a whole bunch of it, kind of like a volume discount, they're going to give us a little bit of a cheaper price. So they knock off 2 cents per pound. Not too much, but every little bit helps, especially if we're buying hundreds of pounds of candy or something like that. So if we had added this one, then the answer would be no. Now, I'm going to change colors. And we're going to do this purchase right here. It says, what if we added this purchase? And notice that it's in quotation marks. It says, would it still be proportional? Yes or no, and then why. So let's write this down. Let's do $0 for 0 pounds. Now, if we tried to show some work for this, and I'm hoping you've got this figured out by now, this is something that you've got to keep track of. Most people know that there's a problem when we're dividing by 0. Or when there's 0 in a division problem, but they forget where it is. The problem here is the 0 in the denominator. So if I did 0 divided by 0, I end up with something, I end up with an error, okay? It's an undefined quantity. In fact, it'll tell you what the problem is. That's the cool part about a calculator. These are smart enough to know, hey, you put the wrong thing in here. We can't divide by 0. It even tells us that the problem is the denominator. It's not the numerator. It's not that the top is 0. It's that the bottom is 0. Okay, so what we're going to put here is we're going to put NA. There is no unit rate for this particular one. Now let's think about this for just a second. Would this still be proportional, yes or no? Well, you might remember, there are a couple reasons for this, but the answer is yes, and you might remember that if we have a proportional relationship, we can write it down as an equation. So we can write it down as y equals k times x. This is the second quantity, and this is the first quantity. So you tell it how many pounds we're going to buy, and it'll tell you how much we're going to have to pay for that. Well, if we don't buy any candy, then the bill that we're going to be charged is going to be 0. So it fits with the pattern. Okay, so I'm just going to write fits with the pattern. And a lot of times it's helpful to think of unit rates in terms of money situations, because then you can kind of tell, yeah, if we didn't buy any candy, we shouldn't be charged anything for that. Okay, so if we do have a 0, 0 in our table, it doesn't really confirm that we have a unit or we have a proportional relationship, but it doesn't mess it up for sure. Okay, if we get the wrong unit rate, then definitely that messes it up and we wouldn't have a proportional relationship. That's why this one is no, because it has the wrong unit rate, and this one is yes, because this doesn't necessarily contradict what's going on here. In fact, it kind of confirms the pattern here, because if we were buying candy, then we wouldn't pay anything if we didn't get any candy. Okay, so let's take a look at how we can see unit rates and proportionality on a graph. And I'm hoping that by now you're starting to remember, hey, we did some of this stuff in 7th grade, and this is just kind of designed to be a reminder. So in this example, it says use the graph to fill in the table and find the unit rate. Is the graph proportional? Why or why not? And then a couple things are noted here. It says by convention we always put the y, it's the second one that goes on the top, the y on the top and the x on the bottom. Now, if you'll get used to this right now, it's going to make things later on in this unit and in units in the future and in other classes much easier. We're always going to be putting the y coordinate on the top and the x coordinate on the bottom. Now, I do have one difference here that you may not have seen in 7th grade or when you did this before. You'll notice that this entire table is not filled out, and that's by design. When you get into older classes, they don't always give you everything on the table. What they expect you to do is they expect you to be able to say, hey, if you're given an x coordinate, can you figure out what the y coordinate is? Or if you're given a y coordinate, can you figure out what the x coordinate is? So we have all the information that we need over here. Remember, this is a picture of the relationship. In fact, I'm going to write that. This is a picture of the relationship. Okay. Relationship. It's a picture of the relationship. So this has all the points we need. Okay. So remember, the x coordinate is the horizontal, the y coordinate is the vertical. So let's take a look at this one right here. The x coordinate says it's -6 and the y coordinate is -2. So let's just double check that. So on the graph, we'd come over here to -6 on the x-axis, and then -2 on the y-axis would be going down. So again, -6 means we go to the left, because the x-coordinate is left or right, and the -2 on the y-coordinate, because it's negative, we don't go up, we go down. So this is the point right here. So that's the point they're talking about. So on that particular one, we have all the information that we need for the unit rate. So we're going to do a -2 over -6. Hopefully we don't need a calculator for that. We're just going to reduce that. We end up with 1/3. So there's the unit rate. Now, there's no labels on here or anything like that, but the unit rate on this one is 1/3. On this one, it gives us the x-coordinate, and we have to find the y-coordinate before we're going to go any further. So if the x-coordinate is 0, what that means is we don't go left or right. So we would be right here. And what we want to figure out here is we want to figure out what the y-coordinate would be. Well, the y-coordinate on the line, when x is 0, we would be right here. So I'm just going to put a dot right there, and notice that that is the origin. So this would be 0, 0. Now I'm going to do a couple more of these to make sure we understand how to find the y-coordinates from a line. So here's what we're going to do. We're going to go over to 3 on the x-axis, +3. So we're going to go over 1, 2, 3. So we're right here. And then we'll put a point on the line right above or below 3. So we're going to follow this line up because the line's above here. Okay, and we're going to put a dot right there. Okay, now that coordinate would be over 3 and if we went up 1 unit, the y coordinate is 1. So we've got an x coordinate of 3 and a y coordinate of 1. So I'm going to put a 1 right there. And then the last one says 6 comma whatever the y coordinate is. So again, we're going to go over to 6 on the x-axis because they gave us the x coordinate, 6 on the x-axis. And then we're going to figure out where the line is. Well, the line's not down here, the line is up here. So I'm going to put a dot right there and let's figure out what that coordinate is. Again, we're over 6 to the right on the y-axis, or x-axis, and then we're going to go up on the y-axis that far. 1, 2, it matches up with 2 right there, so that means the y-coordinate is positive 2. Now all we need to do on each one of these is do the work here, so we're going to do 0 divided by 0. Remember, you can't divide by 0, so I'm going to hit NA on that one. And then 1, second coordinate over the first coordinate, 1 divided by 3, so that is 1/3, okay? And then we're going to do, again, y coordinate over the x coordinate. So we end up with 1/3 on this one right here. So again, the question here is the graph proportional or not? So we're going to say proportional. I'm just going to say proportional. We could abbreviate that with prop or something like that, but we're going to do proportional, and we're going to say same unit rate. Okay, that's the reason why. Okay, so we've got all of our work here. We've stated that it's proportional and that we have the same unit rate, and that's why. And again, this one right here doesn't necessarily mess things up. It just it kind of fits the pattern as we're going through here. We've got this nice straight line here. It's not the wrong unit rate. It's just there is no unit rate when we've got a point of 0, 0. Okay. All right, let's slide down here and let's take a look at the next one. And notice that the XY table on this one, it kind of alternates back and forth. Sometimes they give us the X coordinate, sometimes they give us the Y coordinate. So we're going to practice on this one. Again, if they give us the X coordinate, we're going to go to that point on the X axis and then go up or down depending on where the line is. So we're going to go back to -4. And we're going to figure out where the line is. The line happens to be down here, so I'm going to put a point right there, and let's figure out what those coordinates are. That would be back 4, so there's our -4 in the x direction, and then we have to go down 1, 2, 3, 4 in the y direction. So this is -4, -4. We'll do the unit rates in just a second. Okay, now on this one it gives us the y coordinate of -3. Okay, so on this one we're going to go on the y-axis to -3. So we're going to go down 3, and then since we already went up or down, now we have to go right or left to find where we are on the line. So we're going to go over right here. So it's the point right there. So again, I'll do that again. The y coordinate is -3, so we're going to go on the y-axis to -3, and then we're going to go left to right to find where the line is. On this particular one, we go left. So that would be back 1, 2 points. So this is the x coordinate right here. Even though they gave us the y coordinate first, we went down there and found a point on the line. So this point would be found by going to -2 on the x-axis and -3 on the y-axis. So -2, -3. Again, we'll do the unit rates in just a second, but I want to review here for just a minute. They give us the x coordinate, so we're going to go on the x coordinate to -4, and then we're going to go down to the line. So this one told us whether we go right or left, and then we figure out whether we go up or down to get to the line. On the next one, they told us to go to -3 on the y-axis, so they told us to go down first. If they told us to go up or down, then we're going to figure out whether or not we have to go left or right. In this case, we had to go left 2 units. So -2, -3 is that point right there. Let's do the next one, 0. So 0 on the x-axis, so we're going to be right here, and then in order to be on the line, we have to go down here. Okay, and that would be -2. And then the next one tells us a y coordinate. The y coordinate is 1. So if the y coordinate is 1, we're right here. They told us to go up. So then in order to get on the line, we've got to go either left or right. There's certainly no line over here. So we're going to follow it straight over here, and we get that point right there. So we end up with the y coordinate was 1, and if we go over here, that helps us find the x coordinate, which is 6. Okay. Now, I'm going to pause right here because you may not have done a whole bunch of this before. I want to make sure that you take a second and realize how we do this. If you don't understand how to do this, please make sure you ask a question, get some help, because it's really important to be able to look at a graph and tell what the coordinates are of a particular point. So let's do a little double check right here. So if we have done this correctly, we should be able to find the points that we have over here on the line itself. So if I go to 6 comma 1, 6 is the x coordinate, 1 is the y coordinate, I would go 6 units to the right, positive 6 on the x direction, and then 1 unit in the y direction, up 1 unit, and I end up right there. This one would be don't go right or left because the x coordinate is 0, and this would be down 2 units. So we don't go right or left, we just go down 2 units. So these are all the correct points. So let's go ahead and find the unit rate. Again, second one on the top, first one on the bottom. The y goes on the top, the x goes on the bottom. Okay, I'm going to write that down, y over x here. So this would be a negative divided by a negative is a positive. So this would be 1. And then on this one, let's see, we've got a negative 3, because that's the y coordinate, kind of doing this backwards here, over negative 2. So that would be 3 halves. Also, we could write that as 1.5 if we wanted to. I'm going to circle the 1 and I'm going to circle the 3 halves. This would be better because it is a ratio, so we want to write it as a fraction. That's probably the most useful. Again, the y coordinate on the top, the x coordinate on the bottom. We're going to write NA. Remember, it's dividing by 0 that we have a problem with. If there's a 0 on the bottom, that's not okay. We get an answer that's undefined or doesn't exist. Okay, a 0 on the top would be okay. And then we're going to put a 1 on the top and a 6 on the bottom. So the answer on this one is 1/6. Okay, so there are all of the unit rates. Is the graph proportional? And we're going to say not proportional. Not prop is what I'll say right there. And we're going to say not same unit rate. Now, I'm hoping from these two examples you can remember that in 7th grade you talked about this idea and you found a quick way to look at a graph and tell whether or not it's proportional. So I'm going to slide this down here and I want you to take a look at these. So this one is proportional. This one is not proportional. You'll notice they're kind of tilted about the same. The lines look pretty similar except for where this one goes through the y-axis. So there are a couple ways that we can tell whether or not a graph is representing a proportional relationship. The first thing is, if we're looking at a graph, it has to go through 0, 0. And I'm going to write it this way also. I'm going to say the origin. If you're not familiar with that term, make sure you are, because we kind of use those interchangeably. 0, 0, the very center of the graph, that's called the origin. This one goes through the origin, this one doesn't. That's one of the requirements for it to be proportional. And then the other thing is, this is a nice straight line. That's also a nice straight line, but because it doesn't go through the origin, it's not proportional. So the points must make a straight line. It wouldn't be okay if it were curved or, you know, some weird shape or something like that. It's got to be a straight line and it's got to go through the origin. Okay, good luck on the assignment.